Hello, this is Lucas Chafournier, and my final project was tackling mini challenge 1 of the VAST challenge from 2011. So in this challenge, we are investigating an epidemic, and so we were called in to see how the epidemic started, is it still spreading, and how did it spread. So what I did was I created an interface here that allows you to kind of explore the tweet data and some of the weather data to see if we can figure out what's going on. So I'm going to start by breaking down what the interface looks like. So you can see at the top here, we have a map. What this represents is the convex holes for a given area and its tweets. These big circles represent the centroids of each of these clusters. And these are calculated by running k-means over the GPS coordinates of each tweet. So what this allowed us to do was basically have smaller clusters that we can run some of the ML algorithms on, and it wouldn't take forever and be unresponsive. On the other map over here, what we have is the same map, but in the same cluster centers, but we have a different type of data represented. It's still tweets, and it's actually direct tweets. So when you first log in, what you get is a sample of these tweets just to start us off. Basically, these pluses represent all of the hospitals in the area. And so we represent those so we can see, if there are these big patches of data, we can see if it's clustered on a hospital or if we should take a closer look because it's in the middle of nowhere, which means it's likely where there's a problem. Down here, we have the topic model for a given area. So for cluster 0, topic 0, these are all of the words that contribute to topic 0 here, so for no. And what you can see is if you click on one of these centroids, what will happen is this data will change. And it takes a few seconds because of the amount of data we're dealing with, but you can see there that it changed and that, okay, look, we have all of these symptoms for this topic that show that likely there are a bunch of people that are sick here. And so what we can do is evaluate each of these topics and see which of these represents sickness versus not. So that's controlled by this topic breakdown over here. This allows you to select these. So if I wanted to go and see topic 5, what that'll do is it'll change to life. And in a second, this will pop up, and there we go. And so all of these represented life. We can also change the number of topics. So if we click here to 21, what we'll see in a second is we'll now see the top 21 topics, and it allows us to dig deeper and deeper. And so now we have 20 topics, and we can go through all of these and figure out what's going on. We also have the ability to blacklist words. So like say I wanted to get rid of this go, what we can do is we can type go into this box over here, and it'll blacklist it. And so then that's too generic of a word. Hopefully we'll get more and more refined clusters, basically. And so now we have this don't you just hate it when as our 0, 0 cluster. Another thing we can do is we can select the date. And what that will do is bring up the weather patterns as well as just the tweets for that date. Now I'm going to first use our little search box here. So what we're going to do is we're going to limit these tweets to only showing the tweets that represent flu. What this will do is show us all of the tweets for all of this time period that reference the word flu. And so here now you can see that we have these big clusters of data where these outbreaks are. And these are likely the most densely populated areas versus these rural areas up here. And we can see here there's a lot of clustering here because we're around a hospital and the same here. But over here, there is no hospital, so maybe there's some sort of outbreak here, another stadium or something that we can look at. And so now let's say we want to investigate how this spread. What we can do is we can click on, say, May 3rd, and what that'll do is restrict this map to only show the tweets that reference the flu from that time. And so we can see that the flu is just getting started and is likely starting from over here. You'll also notice that this map over here has changed a bit. And what it does is it shows the average wind speed for that day, as well as the direction of the wind. And so this is showing that the wind is pointing in the, looks like the southeast direction. And so we know that we may be able to compare this with these clusters here and see, okay, maybe the wind is spreading some sort of toxin that's causing this issue. And so we can keep, evaluating and seeing, as time goes on. Let's say we go to May 11th, this will then update to show tweets that reference flu for May 11th. And so we can see that it's grown and it's actually spread a bit down here. But also the wind is still 8 miles per hour, but it's now pointing in the west direction. And so using a combination of all these tools, you can hope to see how this infection spreads, and then eventually, whether it's contained. And so we can maybe see a rate of growth here. So we'll see the May 16th, it's gotten a little bit more up here. Wind is still blowing towards the west. And then finally, we'll go here, which will show all of the tweets. And we'll see if this should hopefully fill in a bit. Yeah, so you can see that it's filled in. But it looks like it's not as populous as these are, and so hopefully maybe it's slowing down, but not necessarily the case. And then here you can see that the wind is also now blowing in the northwest direction. So the wind seems to, as time went on, continue to blow north, which might indicate why there's a bunch of sicknesses here. And that's my project. Thank you for your time.